In this statistics video, we are going to cover more vocabulary, and we're going to focus on data, sampling, and variation in data and sampling. So feel free to pause the video whenever you need to copy down some of these notes. I type them in just so you could easily read them. And we'll start off with what is quantitative data. Now, quantitative data has the root quantity in it, and quantitative data, they're always numbers. Think of that as being something that you could represent with numbers, where qualitative data is categorizing and describing attributes. So, you could call like an iPhone by its color, and qualitative data would be like the quantities of colors that could be there. Qualitative data could also talk about how good something is, if service was rated best, better, excellent, poor. So qualitative data can't be represented well with numbers, where quantitative data is. Now, there are two different types of quantitative data that knowing so will actually help steer you towards what kind of statistical tests you want to use, mostly in your future statistical needs, because quantitative discrete are really talked about data that can be the result of counting. Now, in math, we have a word for that, which are integers. Integers are positive and negative whole numbers, and obviously whole numbers are easily counted. But quantitative continuous data, so the difference between continuous and discrete, is when you have not only counting numbers, but also fractions, decimals, and irrational numbers. You're probably familiar with what a fraction and a decimal is, but an irrational number is a decimal that doesn't repeat itself. One of the famous irrational numbers is pi, but you can make up your own irrational numbers by thinking of a decimal like 0.1211211121112, and notice that pattern is evident, but it's never repeating, and you can't actually write it as a fraction. So an example to telling the difference between continuous and discrete, one of the keys is weight and weather, because they are not only continuously changing, but also if you get to real precise measurement, you're going to get down to non-whole numbers. Whereas a good example of discrete data would be in counting sales or tickets, or again, anything that could be just easily counted. Whereas weight and weather, lengths, for example, can't be easily made into an integer. Like, you can sure measure things by the mile, but that's probably just an estimate, because if you really drill down, it's probably not exactly 5,280 feet. So that is the big difference between quantitative and quantitative discrete and quantitative continuous in talking about quantitative data versus qualitative data. So that might, you might want to have these in front of you when you do the homework. It's easy to get these kind of mixed up around. Now let's talk about what sampling should. This is a good sampling should rule that should hold for the rest of the semester. A sample should have the same characteristics as the population it is representing. As a reminder, sample is a small portion of the population. The population is the group that you're trying to estimate without actually talking to each person in the main population. Of course, that would be ideal, but it's not very feasible. Other than the census, we're probably going to try to do sample distributions rather than trying to count every single person and get that information. So make sure when you get a sample that it has the characteristics of the population it is representing. For example, you don't just want to ask your friends if you want to try to figure out what the entire school or town or city or country is supposed to represent, because your friends it's a subset, but it's probably not a representative set to that entire larger group. So keep in mind that when you do sample, this is probably the gold. This is the gold standard. Now let's talk about types of sampling. Since we're not going to actually go out and gather samples in this introduction class, you have to know what kind of sampling techniques there are. Now, simple random sampling is anytime you get a group of individuals where it's equally likely to be chosen as any other group of individuals. This idea of simple random sampling means that you're picking people completely at random and you don't have any preference of picking one person over the other. So that is one type of sampling. Just do it randomly. Another way to do it is stratifying or stratified sample, where you divide the population into groups called strata and then take a proportionate number from each stratum. So let's say you want to make sure that men and women are represented equally. You basically then divide your groups, divide your subjects into two groups and then make sure you get the same number or same proportionate number in each group. Also, age levels is very important, especially if we're trying to figure out voting populations. You want to make sure that you have a representative stratum from each from each group, so that you're not underrepresenting one group versus another. Now, there's another way to break things up into clusters. It's when you divide the population into clusters or groups and then randomly select some of the clusters. And again, you're going to make sure that these clusters are representative of the whole, but you're not going to pick everyone in your group. You're just going to pick a small cluster so it's basically a subset of your subset, a small group of your smaller group of the population. Cluster sampling is desired just from the fact that it is by definition representative of your whole group. So it will cover a lot of the age and gender and other classifications you want to use when finding your sample. The systematic sample is kind of fun because that is when you pick a random starting point and then you pick every nth piece of data. That's nth, which means that you're just going to say, okay, I'm going to start surveying people as they come out the door, and I'm going to ask every fifth person a question. So the 5 would get in place of that n for nth, so it could be every fifth person that walks out the door, every 10th person, or you could be looking at an assembly line and saying, okay, I'm going to pull every 100th package off this assembly line and check it for proper packaging technique. And it's really used when you can't get to every single person or package or item, but you do enough because you feel like I'm going to catch enough representative data if I just take the 10th, 20th, 30th, 100th thing and take a look at it. Now, all of these techniques of getting samples are great, except that sometimes they're just not feasible. So here's where we have something called convenience sampling. And convenience sampling involves the results from readily available subjects. And you can see that I have in parentheses, this is non-random. This is where, this is who I have in front of me, so I guess I'm going to sample them. And you really have to make sure that you've dotted your I's and crossed your T's, because this is tricky, because you could run into a lot of problems with your sample if this is what you have to survey. But if you're looking at something that's possibly life-threatening or deadly, you may just want to take whatever's in front of you, because you're not going to want to throw out anything that could be perceivably important, but also, you just can't bypass it. Now, here are some further areas of study. Might be good to take a look at how we could look at these techniques in sampling. Now, there is the idea of replacement. Is someone who's picked at random, or some item that's picked at random, do they still have a chance of being picked again? Now, when you do random sampling, you're kind of allowing replacement to happen. So it's possible that you randomly sampled somebody in the lunchroom and you got picked, and then during another time or even in the same moment you got picked again, because it's random. Randomness happens where you can be picked again. Now, surveys are typically done without replacement. We wouldn't want your opinion to count twice. So that's something you have to take care of when you are doing surveys. Now, sampling errors can occur, and we're talking about the errors from the actual process of sampling. For example, if we took a look at the convenience sample, we could have some real sampling errors there. Perhaps there were some twins in the sample that could throw off the data based on their genetic makeup. Possibly the sample size is too small. All of these kind of samples have that kind of trap. So that's what we call a sampling error. It's when your actual process of sampling causes the error. But a non-sampling error is when you have factors not related to the sampling process. Most common is a computer glitch, where you entered in all the correct information, but because of something that went wrong on the computer, a file got corrupted. There's a possibility of a non-sampling error. Now, sampling bias. This is kind of important because we need to talk about some of the problems that can come up in sampling. And a sampling bias is when a sample is collected from a population and some members of the population are not as likely to be chosen as others. Which also could be stated that there could be some people who are more likely to be chosen than others. So this is incredibly important, especially in opinion polls. If you're on a website that supports a position and it asks everybody who goes to the site who already supports the position for an opinion, it's definitely going to be skewed because dissenters are probably not going to that website in the first place. So it's always important to check to see if you have overwhelming support, or a study comes out, there's overwhelming support, figure out if there was sampling bias in that survey, just to maybe discredit it or maybe look at it under a different light. Now, this is the first time we've heard of the word variation. Variation is a very common word in statistics, but if you hear the word variation or spread or dispersion, it really just refers to how spread out the data is. Data can have variation. We are actually going to look at a much more specific kind of variation called the standard deviation. And in terms of box and whisker plots, we're going to look at the interquartile range for percentiles. And so we're going to have some discussion of variation. But in this course, we're going to focus more on standard deviation, which is a little bit better for communicating what you mean about the variation. But this word comes up here, so I just wanted to cover it, because we're just going to loosely talk about it at this level. Now, I also want to kind of throw in something about the sample size rule that's not actually given away at this moment, but it's going to be a recurring theme in many chapters of statistics, and it's called the Rule of 30. It's this idea that once you have a representative sample of 30 people, you actually have a good enough data set. And there are many many ways we could explain this with some mathematical formulas, but right now let's just state very simply and at this level very rudimentarily that if you have 30 pieces of data and it's representative of the whole, that's sufficient. So that's going to kind of stick with us as we look at how we choose tables and tests to qualify and analyze data. All right, so getting close to wrapping this up here, I do want to give you the 10 things that the book wanted to throw in for critical evaluation of data. And also I want to throw in a couple of mine just to add to the book. But the critical evaluation, we really should look at data with a lens of these 10 questions just to make sure that these statistical studies aren't flawed from the get-go. Because if these 10 flaws are in there, you may just have to throw the whole thing out. So obviously, number one, the gold standard is make sure that the group is representative of the whole. Make sure that the person didn't just pick 4 or 5 of their friends or cherry pick 6 people with a disease to proclaim something. And that honestly leads into the biased portion of it all, but the bias can actually just be even more than a representative group. You can actually create surveys that steer people towards answering a certain way by giving a name of something that has a positive or negative connotation. You can really skew your survey data by making it biased in that way. And psychologists really have a tough time in front of them. They are some of the best people to try to figure out this biasness. And so writing a good question is tough because you want to make sure it isn't biased. The self-selected question is asking, are you getting data from people who volunteered? Now, sometimes that's okay, but sometimes it's not, especially if it's an opinion poll. If everybody's volunteering to give their opinion, it's skewed. Think about an online poll. You don't know who is actually doing it and if they're self-selecting themselves to do it and how the traffic got to that online poll. The sample size, we talked about that. You actually can have a sample size less than 30 if it's representative of the whole and fits the distribution of the type of test you're about to use, but let's get into that later. But for the most part, you really should try to have 30 or more, and there's a concept called robustness. So to be robust is to actually mean that the bigger the sample size gets, the more true the answer is. So if you find that you're going beyond 30 and you're starting to stray pretty far away from your original results with the 30 people, then you probably had a trouble with the 30 people. Is there undue influence? And again, the wording of the question can be that undue influence, or perhaps your boss is staring over you while you're taking a survey. This is why when we used to do paper-pencil evaluations of professors, the professor had to leave the room. There was usually an administrator or just nobody in the room while people filled out the survey because they didn't want the professor to be looking at people while they did the survey. That would have undue influence on the survey being taken. How about non-response, refusal, and dropouts? Well, that would be if somebody refused to complete a survey or a follow-up or just dropped out. It's important to see if your sample size changes from one moment of the study to the next. You kind of want to figure out why were there so many dropouts and people maybe refuse to continue with the survey or the data. A very dangerous mistake is people finding causality from correlation. Correlation is this idea that there is, and especially we'll be doing this in a later chapter, there's sometimes a mathematical relationship between two variables. But correlation is not causation. There's definitely possibility that there could be a link, but you can't prove that just due to correlation. So coming up with a causality statement with pure correlation, probably a big stretch. The self-funding and self-interest. Obviously, if you're funding your own study, if you have an agenda, that's pretty important to know. If you're the company of a product and you're funding a study to tell people how awesome the product is, there's some problems with that. You obviously are going to do things like that because you're going to want to make sure your product is awesome and works and people like it, but definitely go for an independent test to make sure that holds up and is repeatable. Now, misleading use of data. That is when you either intentionally or unintentionally present data correctly or incorrectly. So there are just dozens of examples online of misleading statistics in advertising, on news channels, and I always kind of refer to one of the comedy skits I heard with Team Evil versus Team Stupid, because it's possible that they created the data and put it up on a display that wasn't very smart. And there's another situation where someone had the data, and as being part of Team Evil, they accidentally or they intentionally put it up as misleading. So a little props to the comedians who came up with that, John Oliver and Wyatt Cenac, of Team Evil versus Team Stupid on misleading people with data, either through incompetence or through deception. So finally, your critical eye should talk about a confounding event. Did the weather throw off participation? Was there a heat wave or a flood or a snowstorm that caused things to be better or worse than expected? Obviously, diseases have this kind of impact on things, so sometimes the confounding event is a real issue with the data itself. And if that's not stated, then it maybe should be stated. And then I want to throw in one of my own, and it's the problem with published findings, which means that a lot of times when things get published, it's because it's new, or it's a surprising result. And that is generally a problem because there are dozens and dozens and dozens, if not hundreds of studies done each year that are not published that just repeat previously published results. This information has been talked about by not only Freakonomics, which is a podcast, and also National Public Radio, that studies that have been done are difficult to replicate because it's possible that they were published because they showed something new, but they just weren't, like they maybe had a flaw, or they maybe had an unknown flaw. And so you really should take those new results with a grain of salt. And my example here is like chocolate. We have had several multitudes of studies that talk about chocolate's bad for you, chocolate's good for you, it's good in this way, it's bad in this way, because there's been a lot of studies that have been published about chocolate, and they conflict because every time something is found new about this, it's excitedly publishable, and people kind of get drawn to that. And we all love getting drawn to the excitement of the new, especially if it's about something that a lot of people love, like chocolate. Now, it would be not very exciting to publish a survey that said, hey, guess what? The thing that you thought was this way for the last 30 years, well, it's still this way. So that doesn't get a lot of attention. So sometimes when you see a new published study, really dig into it. Check if it's peer-reviewed, check to see the data behind it, sample size, and all these 10 other things. And definitely look at very simple arguments made online, because it's possible one of these 10 things, including this last one that I threw in there, could be trying to influence you without being really data rigorous. So this ends our second of 3 videos to talk about the basics and vocabulary of statistics. Thank you for watching and listening.